All right, well, Lindley, we've been talking in class a lot about weather and things that can affect the weather around us. And two of the really important things we've talked about here in the last week have been temperature, well, actually three of the things have been temperature, pressure, and humidity. Now, we've talked about temperature as just being how warm the air is. And the temperature can affect the air molecules because as the air gets warmer, what happens to those molecules? They
move further apart.
Move apart, right? They spread out more. And as the air gets real cold, what happens?
They come closer together.
Yeah, they press in, move closer together. Now, we're not going to be changing the temperature today, but we are going to be changing the pressure without having to change the temperature because we've got a pump here hooked up to a flask. Now, right now, the air pressure inside here is the same as the room because we've got a nice open system. But when we close it off, we can change that. And I'm just going to take this, we're going to try to push it down in there as good as we can. We've got it closed off, and we've got a pump hooked to it so we can increase pressure. And we talked about pressure just having to do with how close together or how far apart the molecules are. But the last factor that's going to affect what we do today is humidity. And we talked about humidity being the amount of what in the air?
Moisture.
Yeah, the moisture, the water vapor that evaporates up. And that humidity kind of spaces in between the air molecules. So when the air molecules are further apart, more moisture can fit in. When they're close together, there's not a lot of room for moisture. So what I'm going to do, I'm going to let you hold on to the pump. Don't pump it yet. I'm going to push this in one more time. Like I say, we want to get that just as tight in there as we can. All right? Now, when I tell you to, don't start yet, but I'm going to have you pump that. And just be careful, don't pull the flask off by that. Kind of try to hold the pump steady.
Okay.
And I'll hold on to it. Well, let's see. We should be okay there. But just try to hold that steady. And I want you to pump that. Now, a couple of things are going to happen. Number one, you're going to increase the pressure in here. The molecules are going to push closer together. But also in the bottom of this, there's some liquid. We've actually got some alcohol. It tends to turn to a vapor a little bit easier than water, so we're going to use it instead. Water would work, but alcohol I found works a little bit better. And as you increase the pressure, it's going to also put that air pressure down onto the liquid in the bottom. It's going to also pressurize the liquid. And hopefully, if this works right, at some point the pressure will build up enough that we open up the top of our flask, it'll launch the cork out of there, the stopper, but it's also going to greatly and very quickly decrease the pressure in our system. So that means we're going to have more space for water vapor in the air, and we're going to see if we can cause a cloud, that condensation of the water vapor, cause a cloud to form inside our beaker. And this will give us some idea of how pressure and humidity can affect clouds as they're formed. So whenever you're ready, go ahead and start pumping that, and just be ready for it to pop off. Okay, try to pump it a little bit faster. It needs a bit of air in there to build up pressure. All right, need me to get it there?
Yes.
All right, I'll give it a few pumps and let's see if we can get it to build enough pressure inside our flask. All right, so what we have now
It's a cloud.
is a cloud. As that pressure changes inside the flask, the molecules move further apart, more room for water vapor, and we've managed to form a cloud inside our beaker. Now, if we were to put that stopper back on here, give it just a couple pumps and increase the pressure again, you'll see the cloud disappear very quickly because, again, that pressure mashing the molecules closer together, no room for the vapor in it, the vapor gets forced back down to the bottom. So that's just a good little demonstration of how pressure and humidity work together to form the clouds that we see in the sky every day.